Hello friends, welcome back to our channel STM Metatronics, and in this video we will see a mini project called Serializer. So what this project does is, it basically whenever we are pressing the input, it will serialize, or it will give output a serial character as output. Whenever we are pressing button B, it will serially output the character, second character, and whenever we are printing, or whenever we are pressing button number 3, it will send the different character on the serial. Okay, so similarly whenever we are inputting the respective character, let's suppose for this output we are entering X, so this output LED should get on, or this output should get on. Okay, similarly if we enter another designated character, output number 2 will get on, and whenever we are entering the third designated character, output number 3 will be on. Okay, so first we will understand the schematic. For this mini project we are using STM32 F103 C8 controller, which comes as a blue pill board. Now we are using optocoupler PC817. It is easily available in the market. Okay, we are using 100 ohms for the optocoupler LED input. Okay, and these are the digital inputs. Now these are digital inputs, these are push buttons. Okay, momentary latch push buttons, and PA9 is for serially transmit, and PA10 is for RX, serial RX. Okay, now we will understand. We have set the baud rate as 96000. Okay, in code also we have used the baud rate as 96000. Okay, now here what we have done is, the optocoupler is used for isolation. So another end of the optocoupler, that is isolated part, we have used it to drive the output. So this can be any output, like a motor or a relay, or any kind of output. Okay, so basically what we are doing is, we are isolating our controller from the external output peripherals, or external output drives. Okay, so for that we have done is, we have used 200 ohms of resistor. Now this is PNP transistor inside it. Okay, photo transistor, and whenever this LED gets on, this output will be on. Okay, so whenever we are setting this PA4 pin to logic 1, the output LED should be on. Okay, now how this works, like we'll see the functionality working. I'll explain the code in the later part. Okay, so first, if you see, first input pins logic level is logic 0, that is 0. Okay, whenever we are pressing the input pin, the logic gets to 1, and on the serial terminal we get A. Okay, character A. Now when we press button number B, we get character number B, and when we press button number C, we will get character number C. Now the sampling period for this button, or checking whether this button is on or off, we have coded that value as 500 milliseconds. So after every 500 milliseconds it will check if the respective key has been pressed or not, and depending on the respective key, microcontroller will output the respective character. Now see, these three LEDs are off. So these three outputs are off. Okay, now if I go over here and enter X, small x, okay, output 1 will be on. Then if I enter small z, output number 3 will be on, and if I enter small y, output number 2 will be on. Okay, so what we have done is, whenever we are entering or giving the command that X, let's suppose X is the command to turn on the LED output number 1, Y is to turn on the LED output number 2, and Z is for turning on the LED output number 3. Okay, so that we have done. Now if you see, after some time this LED gets off. Okay, how we have coded this, that we will also see. We are not entering any output. Okay, any character over here. So see, now again once that LEDs are off, I'll do X, Y and Z. So these three LED are again off. So after particular amount of period, these three LED will be off. Okay, for that we have used counter. So now we'll go and see the code functionality. Now before coming to the code functionality, I want to show you that, okay, if you go in this design, configure power rails, in the ground net there will be ground and VSS. In the VCC the voltage is 5 volt, VDD and VCC will be there, and for VEE it is 0 volts. Okay, so we have completed that. Yeah, okay. Now coming to the controller, the oscillator frequency should be set to 8 megahertz and the oscillator 32 frequency should be set to 8 megahertz. Okay, and you have to program the or load the hex file according to the program. So these are the only changes that you have to make into the Proteus schematics. Okay, these are push buttons, namely named as buttons in the component section. Okay, PDSS component section. Now we'll come to the code. Okay, so once you come to the STM32 IDE, you have to start with a new project. So click on file, click on new STM32 project. Okay, now it will initialize the library. Here you have to enter STM32 F103C8. Now here on the blue pill board we have STM32 103C8 T6 controller, and from that T6 controller you can select this controller. Now click on give the project name. I have already created this project Serializer. Okay, so give the project name, click on next and click on finish. Okay, so it will lead you to this window. Okay, so here you can see that our controller is STM32 F103C8 T6 controller. Okay, so you have already seen here in our schematic or in our Proteus that we are using these three pins as an input pin. Okay, so PA0, PA1 and PA2, these are connected as input pins or configured as input pins. Okay, now PA4, PA5 and PA6, these are output pins. These are connected to optocoupler input. Okay, so PA4, PA5 and PA6, these are configured as GPIO output. Okay, now we have also used the UART output. Okay, UART asynchronous output with a baud rate of 1600. So here in the connectivity we went to UART mode asynchronous. Okay, and here we have set the baud rate to 96000. So whenever you are selecting this mode as asynchronous, these two pins will be set for the UART communication. Okay, so now we'll go over here in the system core, we'll come to GPIO. Okay, for we'll see PA0, PA1 and PA2, these are configured as input pins. Okay, the GPIO pull up pull down register setting. Okay, register setting, this is configured as pull down. Same goes for PA1 and PA2. Okay, for output pins we have configured output push pull and pull up as pull up. Okay, pull up or down we have configured it as pull up registers. Okay, so for all three output pins we have configured the same configuration. Now coming to clock configuration, we are using the internal RC oscillators, okay, that we have given to the system clock. So this is fairly simple program. Okay, once you configure everything, you have to go click on device configuration, tool code generation. Okay, now here it will generate the tool. So we'll walk through the code from first line of the program. We have not added any external files. Okay, here you can see that we have not added any external files. Okay, now coming over here, so we'll scroll through each of the line. Okay, I will simply scroll through the program. Okay, so we have come to the end of the main program, right? End of the file main.c. Now we'll go to the top of the file. Okay, we'll walk through the code. Now in the int main function, we have already declared few variables, starting with start code, right? We are going to print the STM Metatronic string on the serial. So this will be printed whenever we are rebooting the controller, or we are resetting the whole project, or we are programming the controller once again. Okay, this is simple character array start code. We have given the string. Okay, uint16 ARR size, we have taken the size of this array. Okay, now here we have assigned three codes. Like if you remember, like whenever we are pressing button 1, 2 or 3, we will get certain character output. So these character outputs are defined over here. Okay, so Arduino transmit code 1, Arduino transmit code 2, Arduino transmit code 3. Okay, if you want that our code is working, what I'll do is I'll print it as K L M. Okay, now these will be output characters. Okay, for to turn on these three output LEDs, optocoupler output LEDs, we are inputting certain character. Okay, so these characters are defined over here. Okay, so earlier I have said that it will be X, Y and Z, small case X, Y, Z. So what I'll do is I'll enter it as 1, 2 and 3. So whenever we will press 1, 2 or 3, respective LED, output LED will get on. Okay, this is a uint8 variable. Okay, to receive the character bytes that we are inputting from the serial terminal. Okay, and these are the three counter variables basically. So these are uint8. According to your choice, you can increase this timer. If your timer is going to exceed more than 255, then you will have to change this variable type. Okay, data type. So from uint8 you will have to modify it to uint16 or uint32. Okay, now coming to the while loop. So as I mentioned that we are going to print our start code, that this string at the start of the code. Okay, so for that what we will do is HAL UART transmit, then start code and size of the code. Okay, then we'll come over here. What we will do is here in the if loop we'll check that if GPIO pin 0, GPIO A pin 0 is equals to 1. That means if the button 1 has been pressed. Okay, if the button 1 is pressed, then we will output the Arduino TX code 1. This is of 1 byte. Okay, so this Arduino code TX1 belongs to K, right? So K will be output. Then we are sending two characters, carriage return and new line. So whatever we whenever we are pressing a new or whenever we are pressing the button again, the character will be printed on the next line first column. Okay, so here we are checking button number 1. Here the code is same again. Here we are checking button number 2, GPIO A pin 1. Okay, here GPIO A pin 0, again here GPIO A pin 2. Okay, if it is equals to 1, then we are doing this. Okay, now here you can see that this code is same, right? This if loop is almost similar. These three if loops are almost similar. Only the difference over here is GPIO pin numbers. Okay, GPIO pin numbers and the transmit code. So for pin 0 we will transmit code 1, for pin 1 we will transmit code 2, and for pin 2 we will transmit code 3. Okay, so for GPIO button number 0 we will transmit code 1, button number 2 we will transmit button number code 2, and for button number 3 we will transmit code number 3. Okay, now here we are checking if a new character has been entered or not. Okay, so if no new character has been entered, it will go to simple else condition and it won't do anything. If the entered character is equals to 1, okay, so what it will do is it will turn on this LED which is connected to GPIO 4. So for that what we are doing is HAL GPIO write pin GPIO A pin number 4, we are setting it to 1. Okay, then what we are doing is we are making the command counter equals to 0, and this received code byte we are making it to 0, so that whenever this loop executed again, this TX buffer should be flushed out. Okay, this TX buffer should be flushed before scanning the UART again in the next loop. Okay, if the Arduino, if the code received or whatever we have entered is not equals to RX code, that is code 1, okay, it will check whether the entered character is matching with the code number 2. If it is not matching, it will go to the code number 3 for checking code number 3. Whenever the entered character matches with code number 1, it will set the LED output number 1. So it will turn on the LED output number 1. If it matches with code number 2, it will turn on LED output number 2. And if it matches with code number 3, it will turn on the LED output number 3. Okay, so after doing this, what we are doing is we are clearing that TX buffer, sorry, we are clearing the RX buffer. So we are clearing the received characters. So in the next iteration, it won't go inside this if loop. Okay, that's the agenda of here. With that, what we are doing is we are resetting the counter. Okay, so whenever we are resetting, we are receiving the requested character or expected character, we are resetting that particular counter. Okay, now if you remember that whenever we were entering the character once, and we weren't entering that character for a long time, so after particular delay this LED will get off. This LED will get off. Okay, so that's the same thing we are doing over here in this code. So what we are doing is we are incrementing the counter in each scan. Okay, after 500 millisecond it will come, it will increment the counter. So once the counter reaches count of 20, okay, once the counter reaches count of 20, it means what we are doing is 500 into 20, that will be 10 seconds, right? 500 into 20, that will be 500 milliseconds into 20 seconds, 20, so it will be 10,000 millisecond. Okay, 10,000 millisecond becomes equals to 1 second, right? 10,000 millisecond, 10 seconds. Okay, this becomes equals to 10 seconds. Okay, so what we are doing is we will wait for 10 seconds. If the LED, if the respected character is not received again, we will turn on or turn off that respective output. Okay, that's the code over here. That's the simplest code. This is the simplest mini project, but it can be used to turn on and off various kinds of output that is connected to the optocoupler or isolated outputs. Okay, here you can see that our baud rate is set to 96000. Okay, now if you remember, we have modified our code, that is for K, L, M and 1, 2, 3. Okay, so we'll save this, we'll build the code, we'll go over here, we'll run. Now see, like whenever we have entered the, or whenever we have started this project, right, our STM Metatronic string has been displayed. So see, first we'll check the button functionality. So if we press button 1, we'll get K. Okay, if we press button number 2, it will get to L, and if you press button number 3, it will press M. Now if I keep this button number 3 pressed, okay, after 500 millisecond it will come, it will check whether M is pressed, button number 3 is pressed. So if yes, it will send the M character. So that's why it is sending continuously M character. If I press button number 2 or second button, it will send continuously L character. And if I press and hold button number 1, it will send K character. Okay, now see, what I'll do is I'll enter 1, character 1. So LED number 1 is on, I'll enter character 2, LED 2 is on, and I'll send 3, LED 3 is on. Now what I'll do is I'll continuously send, or I'll continuously press button 1. Okay, so I'm continuously pressing button 1. Okay, but after 10 seconds, LED number 2 and LED number 3 are turned off. Okay, LED number 1 is not turned off because I'm continuously pressing button number 1. Now I'm not pressing button number 1 or any button, I'm not pressing any button. So after 10 seconds, LED output number 1 will also get off. Okay, so let's see that. Yeah, so LED output number 1 is turned off. Okay, so that is the code. One variation we can do over here to eliminate the need of these 3 counters. What we'll do is we'll go over here, we'll eliminate this whole code. Okay, we'll eliminate this whole code. What we'll do is, so whenever we are entering button number 1 or whenever we are sending 1, this pin, right, this output will get off. So it will be like, if we send 1 time, the output will be on. If we again send 1, then output will be off. If we again send 1, output will be on, and if we again send 1, output will be off. Okay, so it will be a toggling effect. So what we'll do is we'll go over here, this and this. Now we'll save. Okay, now what we have to do is we have to go over here, we have to delete this, or what we'll do is we'll go over here and yeah, so likewise. Okay, so we'll build our code, we'll load our code. Okay, STM Metatronics. Now I'll enter 1 1 1 1. So you can see that if I continue to press 1, okay, multiple times, so in alternate time LED will be on, in next time LED will be off, LED will on, LED off, on, off. So as I go on entering 1 multiple times, it will be on off effect. Same goes for 2, on, off, on, off, on, off, on. Now on, off. Okay, so likewise we have completed our code. So there is one more variation in this code is, now here I want to send a string of 15, okay, or I want to send a string of 16 over here, and I want to send a string of 17 over here, okay, not 17, 87, 86, 87. Now what I'll do, I'll need the size of the string, okay, character string, and I'll have to make this as an array. Okay, so what I'll do is uint 16 underscore t array array one size, okay, equals to size of this array. Okay, size of this array. Now I'll do 2 3 size of 2, size of third array, okay, size of second, size of third array. Okay, now what we'll do is we'll go over here, Ctrl X, we'll go over here. Okay, I did not transmit code 1, but here what we will do is array 1 size, array 2 size, and array 3 size. Okay, array 3, and here we will do array 2 size. Okay, likewise we'll modify. Now we'll test our code. So if I enter button number 1, 15, 86 and 87, likewise we have modified our code. Okay, here we can again modify the code. Okay, so instead of giving like array size, okay, we have to enter how many maximum number of characters that we want to receive. So if I want to receive a string of 100 characters, let's suppose, so I have to enter a character of 100 characters. Okay, now this will become a array, so code size will become an array. Okay, so here what I'll do, I'll have to do is I'll have to do array, and I'll have to enter like this. Okay, so if this is received, now instead of doing like this, what I'll have to do is I'll have to compare the string. Okay, so instead of this if, I'll have to return result equals to 1, 2 or 3. Okay, I'll have to compare string number 1, string number 2 and string number 3. Likewise I'll have to modify the code. Okay, so I'll modify the code and I'll show you in the next video, but for this video we have already modified our code. Okay, so we'll check 1 2 2 3 3, then we'll press button number 1, we'll get 15, for button number 2 we'll get 86, and for button number 3 we'll get 87. So if you see here, like we have modified our code, and according to our code we are getting the output. Okay, so this is a simple, fairly simple project, the serializer project. Okay, this can be used to for many devices like IoT, or to drive any output that is isolated using the optocouplers. So yes, and serial, like this serial that you can connect a Bluetooth over here and give the command from Bluetooth. Okay, so that likewise, and instead of these buttons you can use the sensors, different kinds of sensors. So whenever the respective sensor gives you output, it will send a respective code over the Bluetooth to your mobile phone or to the other connected device, Bluetooth connected device. So that's the project. Okay, this is fairly simple project. If you have any doubts, any queries, you can post me in the comments or connect me over the WhatsApp, that is 966 500 1206. Okay, thanks for watching this video. If you like this video, please share with your friends. hit the like button, subscribe. Thank you. We'll see you in the next video.